All right. So now let's take a look. Everyone has his or her victory. There you go. Everyone has his or her note sheet. And what I'd like you to do is turn to the side where there are descriptions of points A being reflected and rotated and things of that nature. We have a unit circle, and we're now going to give values to the point on the unit circle. Let's look at our givens. We're going to rationalize our denominators. Point O has coordinates 0, 0. Okay. Point P has coordinates 1, 0. So if point P has coordinates 1, 0 and O has coordinates 0, 0, what type of circle is this? It's a unit circle. Perfect. Q has coordinates 0, 1 and segment PO is perpendicular to segment QO. Now, we're going to do a little bit of transformation. Point P is mapped under rotation about a point O through the number of degrees or radian, that really should state radian, specified into the name point. Would you all change degrees to radian there? I'm sorry. State the coordinates of the named point. Now, for the first problem, it says point P is rotated about O pi 6th radian to point A. If that happens, do you all see this right triangle? I have a right triangle of pi 6th radian angle there. This angle's 90. We don't even, what's pi 6th in degrees? 30. So this is one of our what type triangles? 30, 60, 90. So the hypotenuse is 1. Does that make sense?
Yeah.
And is 1, that hypotenuse is 1, so what's that mean the short leg is? 1/2. Remember that? And the long leg is 1/2 times the square root of 3. So that long leg would be the square root of 3. Does that make sense?
Yeah.
What would A's coordinates be? What would A's coordinates be? I go over square root of 3 divided by 2, and I go up 1/2. Have I done anything strange, wild, mathematically deviant? Well, that degrees comment, I did. So, turn me in. They're like, challenge accepted. All right, does that make sense to everybody? Yes, no? Okay, looking good. Now let's consider yet another situation. What if point P is rotated about the origin pi 4th radian to B? What type of triangle are we working with there if we have a pi 4th radian? 45, 45, 90. The hypotenuse is still 1. So what does that mean each leg is? Remember, the long leg, or not long leg, but the leg of an isosceles right triangle is equal to what? Well, the hypotenuse is equal to root 2x, right? Root 2x. Does that make sense? So, the leg would equal the hypotenuse divided by the square root of 2. Y'all with me on that? So this leg is going to be 1 divided by the square root of 2. They ask us to rationalize our denominator, so what will we have?
Root 2 over 2.
We multiply by an intelligent 1, so I have the square root of 2 divided by 2. So this side here is square root of 2 divided by 2, and this side here is square root of 2 divided by 2. What would be the coordinates of point B? Excellent. Square root of 2 divided by 2, square root of 2 divided by 2. Is that working for everybody? All right. The next triangulo, well, let's look at the next problem. It says P is rotated about O pi 3rd radian to C. What are the coordinates of C? Well, what's special about that triangle in relation to the first triangle?
It's the same, it's just
They're geometrically they're what?
the same.
Which is the geometry term is
Well, it's the same triangle.
congruent.
Congruent.
They just have different orientation. Yes,
Why is the hypotenuse always 1?
because this point has coordinates 1, 0 and the origin has coordinates 0, 0. Good question. I'm glad you asked it. So I'm not going to do our little 30, 60, 90 stuff. I'm just going to say you have length 1/2. You have length square root of 3 divided by 2. Does that make sense? Hence, what are the coordinates of point C? Excellent. 1/2 root 3 divided by 2. And this is where 1/2 root 3 divided by 2. Hey everybody, what is the equation of that line that I just drew? Y equals x. Exact. X equals y. That's as perfect as y equals x. Are y'all there with me? What do we know about any set of coordinates that would be reflected in the line y equals x?
Inverse function.
The y becomes x and x becomes y. Do y'all see that? It works out. Don't you love mathematics? Now, the next little piece. Now you're going to state the next set of coordinates. I'm going to take away my line and I'm going to hide my triángulos. It says point A is rotated about O, 2 pi divided by 3. So here's point A, and it's rotated about O, 2 pi divided by 3. How many degrees is that?
120.
120. Is that going to end up in A prime? Are y'all there?
Wait,
Yep. This is pi third. That's another pi third. Does that make sense? What do you all think the coordinates of A prime would be? Yes.
Wouldn't it be negative, or like minus root 3 over 2 and then just 1?
Perfect. So you have this minus root 3 divided by 2, comma 1/2. In fact, don't our same rules for transformation in the y-axis hold? We change the SIGN of x. Does that make sense? And then for the next little point tidbit, it says B is reflected in line y to B prime. What would B prime's coordinates be?
Negative root 2.
There you go. Negative root
Negative
2
root
divided by
2.
2. Perfect. Negative root 2 divided by 2, root 2. And then part C says point C is rotated about the point O, pi third radian. So that's 30 degrees, that's 30 degrees, so that's a whole pi third radian to C prime. What are those coordinates? Negative 1/2 square root of 3 divided by 2. And if you're not too hep on finding these using my little transformations, you can just reflect. You get what I mean by that? How many of y'all have figured out the circle? You figured out the circle, right?
Yes.
What would A double prime, B double prime, and C double prime's coordinates be? Do y'all follow that they would have the same magnitude as in our first quadrant, but we would just have 2 negatives? Does that make sense? And then in that fourth quadrant, our x is going to be positive and our y is going to be negative. Does that make sense?
Yeah.
So, looking good. So that leads you to your unit circle here on the page 8, or it says page 8 on your note sheet because this is from a talk I gave in January. Oh no. So, okay. So now you all are ready. We're now to the point from yesterday, or from our last time we met, and the time before, we really started thinking about our theta being our rotation, and the cosine of theta was your x divided by your r. What is r in this instance? Which is, what's the length of the radius? 1. So on a unit circle, cosine theta is equal to our x. What would sine theta be equal to? The y. What would the tangent of theta be equal to? Y to x. Are y'all there? Yes, no?
Yes.
So now I feel very confident that I can ask you what the sine of pi thirds is. I'm thinking that you'll think of the y value at pi third radian, which is root 3 divided by 2. Y'all get what I mean by that? How many people are like, I get it, I don't like it? Okay. What would the cosine of pi fourths be equal to? Root 2 divided by 2. Are you there? If you turn to that back page, you have your angle and radian, your degree and radian values from 0 to 2 pi. That might be helpful. But right now, here's essentially what I'd like. I'd like to quiz you on this tomorrow, but I'd like us to kind of practice some different. Let me give you some parameters. I will only ask you the sine, cosine, or tangent of theta. I won't ask for reciprocals. And I'm going to make theta between 0 and 2 pi, or theta between 0 and 360 degrees. Okay? Are y'all there with me? So this is what your quiz questions would look like. What if I were to say, we've done this. What's the sine of pi force?
2/2.
Root 2 divided by 2. You got it? What's the cosine of pi halves? 0.
1 minus 1.
Oh, you just remembered that from the quiz.
What's the tangent of pi thirds?
No.
Square root of 3. You're getting it. What's the... Okay, I said I wouldn't ask that. I said I wouldn't ask that. What's the tangent of pi?
0. Oh, I
Okay.
just guessed that one.
Now, I think right now you all could do like Quizlets for the unit circle, I bet. Is there a Quizlet for unit circle? I want to give you the period to practice this. Y'all follow what I mean by that? Would you like, why don't you practice for 15 minutes and then I'll start quizzing you. Does that make sense? Now,
For real or
yeah, no, quizzing, like just testing. Let's have a contest among the pods. Let's have a podcast. Let's make this interesting.
I don't want you to wait.
Yes, you can do it.
Are we really having a vlog?
Okay, we're having a pod off.
What's our team
Wait, so do we just quiz each other?
Yeah.
That's a really great team name.
And answer questions. There might be somebody who says, I don't get what she's talking about. Teach them.
It's me.
Oh, like
there
55. Or 50. I got like 51 and it was like something weird.
Yeah, what is that?
He does that to me.
And you put it on the wand. You ever take it off and broke it on
You just took it off.
Who put that on
Who put that on you?
Samuel just walked by.
Show it to Samuel.
Quiet, guys. We still have to. We have to.
I have 10.
Did you already do that?
Of course. What have you guys been doing?
They were solving that.
Go, Jay. Ready? Set.
No. Ready. Set, go.
Alright.
So did you actually think I'm actually?
I'm going with my watch.
That's just
Sorry. Showing you.
Do you think I'll make it?
Okay, let's go.
What happens if you instantly?
Oh gosh, you're still taping for Carrie.
40 seconds.
Boom.
Okay, I see.